In this complex number session 16, we are going to study about number of solutions for a given complex number equation. To study in detail, we are going to discuss two problems. This is the first problem. There we have to prove the equation z square is equal to z bar has 4 solutions, and then we have to prove z cube plus 2z bar is equal to 0 has 5 solutions. Right. Now let's see the first problem. The problem says we have to show that the equation z square is equal to z bar has 4 solutions. Let's take the given part, that is z square is equal to z bar. Now let us try to take modulus on both sides, because if we take modulus on both sides, modulus of z bar is also equal to modulus of z. So everything will be converted in terms of z. So first let's take modulus on both sides. Right. Now modulus is taken on both sides. Now there is a property, that is modulus of z power n is nothing but modulus of z the whole power n. So this power can be taken outside from the modulus. And also that modulus of z bar is nothing but that is equal to modulus of z. Applying these two properties, we'll get the equation as modulus of z square is equal to modulus of z. If this plus modulus of z comes this side, it will become as minus modulus of z. So modulus of z square minus modulus of z is equal to 0. Now modulus of z is common to both, so we can take modulus of z commonly outside. So our answer will be modulus of z into modulus of z minus 1 is equal to 0. So here two cases arises. The first case, this may be equal to 0. The next case, this may be equal to 0. Right. If we consider this first case, that is modulus of z is equal to 0, then you know very well that is in only one case only the modulus value will become 0. That is, that complex number should be equal to 0. That is 0 plus 0 I. Otherwise, modulus value will not become 0. So, if modulus of z is equal to 0, then it automatically indicates that solution to that is otherwise z is nothing but 0 plus 0I. So, in the first case, it gives us the solution z is equal to 0. So here we received one solution. Now let us go to the second part, that is modulus of z minus 1 is equal to 0. Right. So here we are going to see what will be the solution to this. But we must be very careful and we must keep this in our mind. Z square is equal to z bar. That we have to keep it in mind. Right. So the second case is modulus of z minus 1 is equal to 0. Okay. Now if minus 1 comes this side, will become as plus 1. Let us try to square both sides because we want to bring z bar again back. So if we square it, modulus of z square is equal to 1 square, that is equal to 1. You know this property, modulus of z square can be written as z into z bar. So instead of this modulus of z square, we can write z into z bar. So now z into z bar is equal to 1. But already you know from the given, that is z square is equal to z bar. So instead of this z bar, we can write that as z square. If we replace it, that is z into z square equal to 1. Now if we simplify, the answer is z cube is equal to 1. So since it is a cubic equation, surely there will be 3 solutions. Right. So for z cube is equal to 1 implies it has 3 solutions. Already we have a solution, that is z is equal to 0 is one more solution. Totally here 3 and here 1. So there are 4 solutions. So we have proved the equation z square is equal to z bar has 4 solutions. So from this problem you can understand one thing. First, if the problem has z as well as z bar, take modulus on both sides and make that z bar into modulus of z using the property. After that, see the element which has modulus of z square and apply the formula z into z bar. This is the key concept for these type of problems. Right. Keeping this in mind, let us go to the second sum, that is problem number 2. Here we have to show z cube plus 2z bar is equal to 0 has 5 solutions. Right, how to do this? The same way we are going to do it. Let us make this plus 2z bar to move to right hand side. So z cube plus 2z bar is equal to 0. So z cube is equal to minus 2z bar. That's good. Now let us remove this z bar and let us try to make that as z. So for that, let us take modulus on both sides. So if we take modulus, it will be like this. Right. Now, you know very well, whenever if you want to take a number outside the modulus, there is no need of worrying because the same number will be coming out. Only the thing is, if it is positive, the one which is coming out will be positive. If it is negative, the one which is coming outside will also be again positive, because whenever it comes out of the modulus, the value will be always positive. So the next step, modulus of z cube is equal to 2 into modulus of z bar. And you know the two properties about modulus of z power n, that is equal to modulus of z the whole power n, and modulus of z bar is equal to z. Let us apply these two property here. So this modulus of z cube can be written as modulus of z the whole cube, and modulus of z bar can be written as modulus of z using this property. So we have answer like this. Right. That's good. Now this plus part is brought to this side and became minus 2 modulus of z. Now modulus of z is common for these two. So let us try to take modulus of z commonly outside. Then the answer will be modulus of z into modulus of z square minus 2. Again, as in the first problem, the two cases are modulus of z is equal to 0, and the next case, modulus of z square minus 2 is equal to 0. As I told you already, modulus of z is equal to 0 is possible only when z is equal to 0. So one solution is z is equal to 0. So for the first case, when modulus of z is equal to 0, it gives us one solution, that is z is equal to 0. The second case is modulus of z square minus 2 is equal to 0. The next case is modulus of z square minus 2 is equal to 0. So using this, we are going to solve the equation further. Moreover, we must remember this clue. The clue is z cube plus 2z bar is equal to 0. We have to keep in our mind. This is foremost and very important clue and main equation for the complex number problem. Right. Now let us try to solve it. That is modulus of z square minus 2 is equal to 0. If minus 2 comes, this side will become modulus of z square is equal to 2. So it's very simple now. There is no need of squaring because already we have modulus of z square. For modulus of z square, we have the property, that is z into z bar. So instead of modulus of z square, we can write z into z bar. So now it becomes z into z bar is equal to 2. Right. Now think about the clue or the main equation. The equation says z cube is equal to minus 2 into z bar. In case, in this equation, if you have minus 2 z bar, right, minus 2 z bar, we can replace that by z cube, because the main equation is z cube plus 2z bar is equal to 0. When plus 2z bar comes this side, it will become minus 2z bar. So if you have minus 2z bar, that can be written as z cube, but we have z bar alone. So let us try to multiply both the side by minus 2, right? If we multiply, we'll get equation like this: z into minus 2z bar is equal to 2 into minus 2. Both the sides are multiplied by minus 2. Now, instead of minus 2z bar, we can write z cube. Instead of this, instead of minus 2 into z bar, we can write z cube. Hence, the equation becomes z into z cube is equal to 2 into minus 2 minus 4. If we simplify it, our answer will be z power 4 is equal to minus 4. That is z power 4 plus 4 is equal to 0. Right? If you see, the power is 4. Degree of the equation is 4. Hence, we'll have 4 solutions for this equation. Surely we'll get 4 solutions for this equation. So, for this equation, we received 4 solutions. Already for modulus of z is equal to 0, we received z is equal to 0 as one solution. So, if you consider these two, there are 5 solutions. Here 4 and here 1. So the total solutions are 5. So now we have proved z cube plus 2z bar is equal to 0 has 5 solutions. So if we consider the two problems, both are almost in the same method. So if you go through this and you practice some more problems, then it will be easy for you to proceed in an easy way. Keep these things in your mind and try to do your exercises and example problems. That will be helpful. Thank you.